I don't have a lot of time since it's 10:53. If I remember correctly, I was I was working with the operating system, checking all of the jumps, and then I didn't compile because the timer had went off last stream. So let's compile this, or I guess the term is assemble. We gotta take the files in. This would be os.asm. And then I think from here, the bootloader should still be good. I just need to combine it. So let's go for wait, there's one more thing. You gotta combine the files. We do the combination. What was it? Oh yeah. Okay. Swap over here. And I believe we still have the right breakpoints. Here. I think this is correct. We don't catch this because typically it's not a runaway execution, but just in case. Since there are no files, to load from, and I don't think we even properly set up the file name to load from. Do we? Dang it, I'm gonna need. What did I write here? 53, 54. It's start, isn't it? 41, 52. It is start. So, once we have a program we want to start execution with, we just need to name it start, and then this will work. How far are we into execution? It does not look correct. That looks very, very wrong. We are executing way out of bounds. Alright, you know what? First, it didn't get to. It didn't break on 3000, so I'm guessing it was jumping further than that. Nah, I don't think preemptive is the correct term to use here. Let's move that, and that was fast. Man, I did not know how slow breakpoints made this thing. Apparently, it makes it run at a snail's pace. Just to check. Exited with code 0. Is this accurate, or am I just... Oh, it is absolutely not accurate. Well, I mean, I can at least... I think this is all correct, and I think I've checked this before. Then again, I should probably check at 0. What's going on at 0? I mean, this looks like valid instructions. 7078. I don't know about that one, but otherwise it looks perfectly normal. Or what, is this the arbitrary value that I have denoted before? Is it? No, it would be here. No, there should be FFFF. Hmm. Well, so I caught execution, so the breakpoints are indeed working, so I don't have to worry about that. That means that somewhere uh, I am jumping that skips both of these. I do wonder, but I don't want to set breakpoints because they slow things down to a halt. But maybe I can do something. Reached? Hmm. Midway is not exactly the correct term to use, but hmm. Does that actually stop anything? I'm gonna. No, it does not. Okay, so I need somewhere to store this. So okay, so I have to type something. But here's the point that I now want to set the breakpoint for. Actually, I'm gonna set it right here. I'm gonna make some conditions. Actually, I'm gonna set it right here. The conditions I'm going to do are to look out for uh, particular instructions. Let me get up my quick reference table. And the things I'm going to look out for are 0x0301 or 0x0302 or 0304, 0303. as far as I know, I don't use registered jumps. Most jumps can't be registered jumps, but the actual unconditional jump instruction can. I don't know why I did that, but I did. So I suppose it's there. Let's see, it would be P1T, or no, OP1D. Yeah. Okay, so jump to OP1D from register program counter. And with this, we can now continue. It is slowing down to a halt, but at least I could minimize the amount or the time for which it slows down to not take literally forever. Dang, this is slow. I'm not seeing anything out of the ordinary yet. It seems like it's going in a loop. Do I have uh, loops that take this long? All right, let's see. So these would just go to here. This seems in oh wait, no, hold on, it skips past. Sorry, I'm looking at the OS code and uh, to pass the time that this takes. So we skip. What is this at these points? It seems to cycle between uh, 3 jump points, and I'm wondering if they are uh, innocently jumping around or if there's something going on. So let's open up the OS file. Wrong one. That's the assembly file. Uh, we want the binary file. os.bin. Right, so we have we have from let's see. We jump to BO from 170. We jump to 110 from C8. We jump to 178 from 138. Okay, so there's a pattern going on. What is B0? Well, we have to multiply by 2 to get the offset here. B0 times 2, 160. 0101. We move to B from, this is a pointer, so we move to B from A. All right, that looks like this, but it looks like this, but it could also be this. And since this looks a lot closer to the very beginning, I don't know that that would be correct. However, we can look at the other instructions. So we have another move. Both cases also have move. 0001, which is a register. 02, which means register C. Both cases do move to register C right after. 02, an immediate 02. And that gives us a clue because only WRAM lookup actually copies the constant 2 to C. Then we should see a compare 0101, 0102, which is a comparison between B and C. And then a jump of equal, which is a 0302. And we do. We should then see move 0 into, yeah, 0 into C, compare B and C again, and jump of equal yet again. And we do. So we're right here. All right, so it looks like we're in the workram lookup. This has me confused and concerned because there's not a whole lot of workram devices that I've implemented. There's like 1, 2, 3, 4. There's like 4. Let me double check that that is indeed the case. Add device, and we go to definition. 02 is a small RAM device, and that is the only small RAM device we add. So we are jumping around between 3 different spots, and it seems like we're stuck in workram lookup. So we jump to B0, which is this. I'm going to put a comment. just so that way I can keep track. Then from here, I will try to identify the other locations. So we jump to 178. To F0. Zero one zero one, and it comes after I think a jump. Okay. I think it would be I think it would be the workram test dbank. Let's see. 0101 000 0003, which is a direct memory. 4301, which is indeed what we're looking at. 0001 0000, which we're moving into. Hmm. One lookup. What does this even do? All right. Then we have 110. That was obvious enough that I should probably have foreseen it being 220. Okay, 0202, which is subtraction. So I think it would be WRAM copy, which 0202 0001 000. So register A and a constant of 1. 0402, which is an interrupt. We have a constant of 1. Should we have a constant of 3? We do. And we have a value, or a register A. 0101, which is a move instruction. And I can already tell that it's correct. This is W, and this is FFFE, which do appear. And the next one is 1111, which is also there. Okay. Let's write this down. Now let's look at the jump locations, particularly where they're jumping from. I should mark that these are jump to. Then again, there's also the label right before that would give me context, but I imagine I could very easily miss that. All right, let's see. C8 divided by, no, C8 times 2, 190, 0302. And since I know it comes after, the B0 and before 110, I only have to look within there. And only at the jump locations. So we have JEQ 190. I believe this is before we increment the program counter, so I don't think I have to do any adjustment for that. 0302, we definitely find a jump instruction here, and it is indeed a JEQ. But what comes after it? A 0101, and we move into register C, the value of 0. Then we should find a comparison, and there we go. We have 170, which, I mean, I can already tell where it is. It is literally one instruction before a different jump, which also is completely redundant. And then we have, let's see, 138. $270, and that's a 0302, which is, I believe, a jump if equal. Yeah, jump if equal. There's only one jump if equal between 170 and 110, so I'm guessing that's it. But we should also find that it has a comparison before, which is between 4 and 6, which is correct. Registers that are identified by 4 and 6. And that was 138. Okay. Now we have this. Why are we jumping around? So first, this jump could probably be completely eliminated if I just reordered these and then just remove this part. Because I don't think I use this anywhere but right here. I don't use it above, and below, especially far below, might not make a whole lot of sense. Since this is just code to initialize the system into a state that it wants to work with. So, so first thing, right? TS plan. I'm moving this to the other view. So, what is this? 4301 system data bank. Okay, so we're getting the specific bank for the system data bank, but it seems that we keep doing this over and over again. actually, let's see. Will be a few instructions, then we'll write. But what is the register A at this moment? So at 110, we subtract 1 from A, interrupt 0, 0, 1, 0, 3, 0, A. We move FFFE into W and 1 into Y. We compare W and Y. Oh, hold on, we move this. Actually, I need to double check the bootloader because I don't think FFFE is what I use. It is not. All banks would have the value FFFF. However, it doesn't seem to be taking note of that because it seems that W and Y are seen to be equal in this case. Because it takes the jump. One 120. So W should change. 128. What is 7791? Because I don't use 7791 anymore. Do I write some code wrong and it just doesn't execute? I'm almost certain that A is incorrect at this point. So, uh, okay. So A is supposed to be, if I remember correctly, it's supposed to be the ID of the device that we want. Our interrupt is 3, and that's what's here. And we have A. A is currently equal to hex 48,000 or 4,802, which is not correct because we do not have anywhere near 4,802 devices, let alone RAM devices, installed. So I know what I want to do here. I don't know why I took the road that I did. Okay, so it seems like we get past the non-volatile memory part where we're supposed to copy that to specific area. I think we were supposed to copy it to 4304. Do we find 4304 anywhere? We do. So we can't just do the same thing here because we also want to have banks available for programs to be within. All right. So to begin, we need to iterate through all the devices. I'm gonna do one thing. I'm gonna copy this, make a new document, put it here, and I'm going to delete everything here. So that way I can work from anew. Okay. So to begin, I think the first thing I want to do is actually try clearing out all of these uh, and I think this. So we actually need a few different work ramp devices. We need the system data bank and we need the world title data bank. For this, since we don't have anything here, we don't care what's there. After we have those two in place, we want to have all of this filled out as much as we can. Okay, so let's begin. I'm thinking we have everything cleared. We hold a state variable in Z. Z will hold what particular bank we're looking for. It will start with the system data bank, then the world tile data bank, then once it hits state 2, starting from 0, it will just fill these up in succession. Our comparison uh, variable will be the register W. Since it's not necessary that I'm going to be looking for the same constant, uh, or looking against the same constant, it's technically not a constant since it does vary. Also, it's a register, so it does that normally. I mean, with programming, you can, and again, just most things in a computer are variable. The only things that are truly constant are, well, I guess the instruction set. Like most RAM or most ROM is like EEPROM, and you can technically rewrite it. Or at least most ROM that I have physical access to. I got a few chips in a drawer over here. In any case, getting a little off topic. Okay, so this should be here instead of tacked down at the bottom. And I think that's going to be all at the moment. So first we'll need to check if something is the work RAM device or is a work RAM device. So what we want to do, actually, let's see. Nope, I think we're good. Is we need a variable a, which we'll check, but we also need the device table, a index into the device table, so that will be B. It's device ID and device type. So A, what is at B? Then compare A to W. No, wait, hold on. This would be device ID. The device type would be the next variable. So now we should have the device type, and we can interrupt the MMC with requests that we change the last bank, if I remember correctly. 03 is bank 4. Interrupt 03 changes bank 4. A. Actually, no, wait, I'm wrong here. We got to do this later. Right now, we should do a comparison. I'm actually just going to have this 0 here and move in the variable as I need it. Since I'm going to need to Then within here, since I believe we write a pair of 00, 0000 technically, uh, it should be that the device ID and the device type of the terminator are both 0. No, compare. This will be our exit condition, so we'll wram skip, and hopefully at this point we have something filled in for our uh, our system data bank and uh, world tile bank, and hopefully at least one program bank. So before we do, but if they're not equal, then we want to increment b by 2. To get the next device type and jump back to the beginning. But we still need to write our exit check, which will check the state of, or we'll check Z. If it is not equal, that is, if it's less than, then we want to jump to our catastrophic failure. Otherwise, if it is 2, then we want to do another check. Three F. Otherwise, we're good to go. After all of that, we need this. Just double checking the jumps. So we skip all of that. And we need to, let's see, we know that we're working with a workram device, but we also have to check if this workram device has already been used. Particularly if it is the one we're working within already, or if it's free to be used. So, as I know, the device table won't contain repeat devices. Then we should not have to worry about devices being repeated, but we still might have an issue if we aren't looking out for things properly. What what would be at the end of workgram? I think I can just stop that right now. I had the I had this open in the background. Okay, so if we ah, I am a little bit stuck on what to do. Perhaps checking the state first. So, and z is our state variable, so we want to I'm gonna make some comments before I go. I think that's good annotation for now. So, that's going to be it for tonight. If you're watching the stream, thank you. If you're watching later on YouTube, thank you. It's going to be it for me. So until I see you again, this is goodbye.